Hey guys, so I was initially going to do a roleplay video today, attempt one since I haven't done one before, but I seem to have gotten myself sick, and I still want to be able to do a video for you guys. I don't know if you can tell in my voice that I'm sick, but I'm sitting here sipping on this apple cider out of a Little Mermaid mug. And I figured, rather than doing a front-facing video where you would see my face and all of its grossness, my nose is probably quite red, but rather than doing that, I would do a video of this kind today, because I recently found this chemistry modeling set from back when I was in college, and I took an organic chemistry class and found out that I was no good at chemistry. But for the class I had to get this modeling set, and while I never ended up quite finishing the class due to life, and I don't really want to go into it, but I ended up having to drop the class. But I still have this chemistry set, and I figured I would try and put some things together for you. Now, I tell you that I had to drop the class because it is one of my two excuses as to why my chemistry is not as good as it used to be. Firstly, I did not study chemistry. That was not my major subject of study. I studied psychology, so this was quite out of my element, no pun intended. And also because it's been years since I took this class. You may or may not be able to see the dust on the box, but yeah, it's been quite a while, so I will probably only be putting together simple molecular structures. Maybe a few more complicated ones if they have the diagrams inside, because I know some of them they have diagrams for. Alright, so let's get started. Alright, so the top here, it tells us that each of these little balls is for a different kind of element. So the whites are hydrogen, the blacks are carbon, the reds are oxygen, the blues are nitrogen, the greens are chlorine, the oranges are bromine, and the purples are iodine. There are also these little sticks, which are the bonds between the elements, and I don't know quite as much about that, except that sometimes, you can see in this one here, sometimes there are single bonds and sometimes there are double bonds. I don't know if you can do triple bonds. Maybe... I don't know. I also don't know what this is, where you just kind of stick them together. I'm sure if I had finished the class I would have more knowledge on how these worked. But anyway, here we go. Comes with this little thing to, I guess, pry them apart, because sometimes it can be quite difficult. Let's see. Yes, so they do have some diagrams for certain elements. Let's start with the basic H2O. So hydrogen is white, and that's 2 of O. Oxygen is red. Wait, no, 2 of hydrogen and 1 of oxygen. There we go. See, I told you it's been a while. And I don't know which which of these I'm supposed to use, so I am just going to use whatever makes it look right, because that's how I roll. So there's the first H. It's the same length. And come on, come on. There we go. The second H. So now we have H2O. Let's see, what else can we make? We can make CO2. So here's one C. And then O2, that's two of these oxygens. Now I believe carbon has 4 bonds, so it must double bond to each of these. I don't think these little ones look like they'll be big enough, so maybe I'll have to use these for the double bonds, because I don't think these look like they can bend. So let's put this one down first. There we go. First one. Second one. Come on. Third one. And the fourth one. Now we can double bond each of these. Let me see. That work? Oh, yes, it does. This one's not quite going in, but it seems to be holding on sturdy enough. And then let's do this one. There we go. We have somewhat wonky looking CO2. And let me see, what else can we make in here that looks fairly simple? See, the problem here is that these pictures are all black and white. It's a little bit hard to tell. You can tell, like, these are the carbons, these are the hydrogens, but it's hard to tell with the ones that are gray. Like, is that one a red? Is it a blue? And this one doesn't show you, like, some of them show up like this, where it tells you, like, carbon, carbon, hydrogen, hydrogen. But this doesn't have that next to it. And that would make it a lot easier. Let me see. Now I know that sugar is C6H12O6. But I don't know if we would have, let me see, H12, so they have, how many does it say there are? Yes, there are 24 hydrogens, so I'll definitely have enough H. C6, there are 14, we've used up 3. O6, there are 8, we've used up 3, so we'll need to, well, we might have barely enough, provided I haven't lost one, but we would also need to, we would also need to find the structure in here, because I don't know that structure off the top of my head. Yeah, that's not in here. Let's see what else we can find in here. There's aspirin. That looks awfully large, though. Oh, but they have both pictures. See this one? They have both pictures. So that ring is this here. And that is called a benzene ring. It's a particular type of structure that you find in a lot of organic chemistry, consisting of carbon and hydrogen atoms in a ring type structure like that. And then usually a lot of molecules will have a benzene ring and some things kind of hanging off of it. I know there's a name for that, but I don't remember what it is. So, vanillin, which I don't think it's vanilla, it sounds like vanilla, has a benzene ring with this the C, H, and O over here, a little C with 3 H's and an O sticking off the end here, a little plus sign, and then an OH tag on the bottom there. And then aspirin is a benzene ring with COOH on top. And what is this? C2H3O2? I don't know if that's how you would say it. I also don't know if you'll have enough time to make the aspirin, but that is what it looks like. And let's see, that's 1, 2, 3, 4, 5, 6, 7, 8, and 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh wait, I've lost count. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have exactly as much carbon as we need. I don't think I want to make something quite this complicated, though. Why don't we just... I kind of want to just stick random ones together. If there are any chemistry students out there, I'm sorry. I'm aware that whatever I am making right now is probably not a real thing. Let me see. This one just has 1 on the end. Maybe I can do this. This video is already 13 minutes and I don't want to make it too long. Otherwise I would have made the aspirin or the sugar. Let's see what else I can put. Carbon. Oops, these guys have fallen out back here. Carbons tend to be a key part of organic chemistry because you can bond them 4 times, and they're, I think, the lightest element that you can bond 4 times. There doesn't seem to be a periodic table in here, otherwise I would show you in more detail, but let's see. Basically, with certain exceptions, if you go along the periodic table of elements, each column will tell you how many bonds it can make. And that's, well, it tells you how many electrons it has in its outer shell. And I'm trying to see how I can explain this to make it something that everyone can understand. Basically, they want to have a total of 8 in their outer shell, or most of them do. So carbon already has 4, which means that if it bonds with 4, if it makes 4 bonds, then it will have a total of 8. So here, carbon has 4, and then it gets 2 from oxygen here, 2 from oxygen here, makes a total of 4. And it sort of shares them, so each bond is sort of 2 electrons that are being shared. I just want to make some sort of molecular structure that uses all of the different colors here. Because when it comes to chemistry at least, more, I guess, artist than scientist. I was never very good at knowing exactly what the structures were, what the names of them were, but these sort of made it easier for me to see, like, this is what water looks like, this is what CO2 looks like, or carbon dioxide. Let me see, we have, maybe we can make a double bond here. Not quite gonna fit, okay. So maybe if I put this here, then I will be able to double bond it. There we go. There we go. Okay, so then I can stick a little green here. Let's see. Okay, close enough. Stick a little green here. What do we have left? Let's see. We've used everything but we have purple and we have white. Maybe instead of this green, we can stick on purple. And I can stick white here. And have I used everything? I think so. So there we go. We have a hydrocarbon. Hydrogen, carbon, oxygen, nitrogen, chlorine, bromine, iodine. I don't think this actually exists, but it looks kind of cool and it was fun to make. Kind of looks like a little horse. And I think that'll be it. I we'll see you guys next time then. Bye.